All right, welcome to Principles of Energy, preparation for exam 2. This is working on the questions that were given as examples on the study guide. We're going to start with question 1, and really quick, this image in the study guide that I zoomed in will be the equation box, so you can select one of those two equations to help you answer the questions, and these are conversions to help you convert units. And so starting with question 1, at 24 feet squared, single pane glass door has an R value of 1.54, loses a great amount of energy or a great amount of heat. How much energy is lost in a 4,500 degree day zoning? And so right away there's a degree day in my unit. I want to know the amount lost, and so the unit that also matches the equation is the Q total. And so from there I can pretty much use the information presented and plug it right into the Q total. So the 1 over the R value is right there. I'm going to do 1 divided by the 1.54, sorry, decimal didn't draw in, and that's in the unit of R value, which is feet squared, hours, degrees Fahrenheit, and that's all over BTUs. Then I'm going to do it times my area, which is 24 feet squared, and this is all times the 24 hours in a day, and that's times my degree day of 4,500, and that is, and I'm sorry it's squishy here, 4,500, and that's in the unit of a day, degree Fahrenheit, over 1 year. So that's my unit. So this is pretty straightforward. I'm going to do my 1 divided by my 1.54 first, and then times by the 24, times by the 24, times by the 4,500. As for units, the feet squared and feet squared will cross out. My hours will cross out with my hours. My degrees Fahrenheit with my degrees Fahrenheit over here. Days will cross out with days, and I'll be left with BTU and year. So I plug the whole problem into my calculator, and I get 1683116, and it's 0.88, so I'm going to round up to the 9, and that is BTUs per year. So that's my unit. So that's my answer for question 1, and I'm going to clean up my page, and then we'll start question 2. All right, so question 2, how much energy would I lose if I inserted a 1-inch bubble sheet with an R value of 2.5 over a window in the question above? And it should say door. We went through that in class. I apologize about that. Hint, use the information above to answer the window still exists, just another layer on it. So basically I still have the window. I'm just putting a bubble sheet on top of the window, which means that it's the same size of window. It's just its capacity, its R capacities is the original R capacity of 1.54 plus the R capacity of the 2.5, which is the bubble sheet. So now knowing that, I can basically set up my equation where I'm going to do my 1 over both R's, the sum of both R's. So I'm going to do my 2.5 plus my 1.54, and same units for R values, which is the feet squared, hours, degrees Fahrenheit over a BTU. This is all times the area, which is still 24 feet squared, times my 24 hours in a day, and times my 4,500, sorry, not reading, 4,500 degree day zoning. Degree day zoning is going to be in days and degrees Fahrenheit over 1 year. So once again, units crossing out will be feet squared and feet squared, hours and hours, degrees Fahrenheit, days and days. And so now I just have to add my 2.5 plus my 1.54 and then divide that number, which is like 4.04, is going to be divided into the 1. So it's going to be 1 divided by 4.04. And when I do that and get my new answer of 46158 it's 1.5, so I'm going to round up and put a 2, and that's going to be in a BTU over a year. So that would be my answer to question 2. All right, last question set for our examples, which is question 3. Calculate the total heat transfer for 24 hours through a glass greenhouse with an R value of 2.16 that measures 980 feet squared, with heating set at 95 and the cold outdoor temperature of 35 degrees Fahrenheit. The heat is electric and costs 87 cents per kilowatt. How much does the lost energy cost? All right, so this problem is over a short period of time, and it has a change in temperature in my problem because I have the temperature here, the temperature here, and I have a small amount of time there. And so knowing that, I'm going to use this equation. Just as a to remind you of what you're going to do, because I have time down here that I'm trying to equate for, instead of my total being BTU over 1 hour, I'm going to move little time over to the other side. So the new way of looking at the equation would be QC is equal to 1 over the R value times its area times its change in temperature times its little time. So now I just have to plug all these pieces into the equation to get the answer in the information. So I'm going to have 1 over my 2.16, and that's in feet squared, hours, degrees Fahrenheit, over BTU, times that by my area of 980 feet squared, times this by my change in temperature, which is 95 degrees Fahrenheit minus 35 degrees Fahrenheit, so that's going to be 60, times my 24 hours. And my problem. As far as units go, I'm going to have feet squared and feet squared, hours with hours, and degrees Fahrenheit with degrees Fahrenheit, and I'm going to be left with just the unit of BTUs. So first step would be 1 divided by 2.16. And then I'm going to times that by 980, times that by my 60 degrees, times my 24 hours. And the answer that I get is 65333, and then it's 3 repeating some more, so I'm going to round up to 4 BTUs. All right, so that's part 1. The next part of the question asks me to find how much this is going to cost me, this energy. And we know that it's per kilowatt hour, so I have to change my BTUs to kilowatt hours. To do that, I'm going to use right up here where I have my conversion. I'm going to divide this by 3,413, and that is BTUs per 1 kilowatt hour. So my BTUs will cross out, and I will be left with my answer in kilowatt hours. When I do that, I get 191.4 kilowatt hours. And the last part is to find out how much this is going to cost me. Since it's 87 cents per kilowatt hour, I'm going to times this by 87 cents. And I will get how much loss of energy, and that will be my final answer. And that gives me $166.54. So that's my final answer, and that's how I would do the third question. So best of luck trying to study, and see you on Monday's class.